Let's do a quick review. In the first lessons, we talked about what? We're not going to actually solve them, but let's just keep it fresh in our minds. What were some of our first lessons all about?
Eating.
No. Multiplication. So we talked about finding equivalent fractions using multiplications. Multiplication. We also did equivalent fractions using division. Remember, that's all. The only thing we need to remember about that is whatever you do to the bottom, you have to do to the top. Whatever you do to the top, you must do to the bottom. If you multiply by 3, you must multiply by 3. If you divide by 2, you must divide by 2. You guys, that's 100% better than where we were a couple of days ago. Believe it or not.
Unbelievable.
And all of you are going, well, Mr. Adamson, of course, duh. Be proud of yourselves, because that was not a duh question a week ago. That was, I'm not sure.
You should have seen their faces.
Yeah. So be proud of yourselves. Whatever you do to the bottom, you must do the top. Great job. And then we talked about other equivalent fractions. We talked about finding equivalent or comparing fractions. And we talked about how if the denominators are the same, the bigger numerator is the bigger fraction. The larger denominator or numerator is the bigger fraction. And then we talked about how if we have fractions with equal numerators, it was kind of the opposite. The fraction with the smaller denominator is the winner. Because here you have 2 of 5 pieces. Here you have 2 of 6 pieces. These pieces are smaller. These pieces are bigger. You have 2 biggers. Here you have 2 smallers.
What is one tool that we use to solve that? Drawing pictures, right? To help us visualize it.
And then we talked about comparing fractions where we'd have to get down and dirty. And that's what I call what we just got done talking about up here. That's down and dirty math. You're going to get your hands dirty in those math problems. That's not going to be a problem that you can just sit back and go, oh, I can just look. I can just picture shop, or I can just window shop and figure these out by just looking at the numerators and denominators. No, I have to actually do the work. That's what we've accomplished so far. Today we're going to talk about fractions that are actually bigger than one whole. Let me give you an example. So, Mr. Adamson officiates football, and tonight after the game in the Myra, myself and the 4 guys I work with, Joe and Phil and Trevor and Rick. Nope, I don't officiate with Bob. Trevor, Joe, Phil, and Rick. We're going to go get pizza afterwards. This is a true story. And let's imagine that each of us are going to eat half of a pizza. So I get half, Trevor gets half, Joe gets half, Phil gets half, and Rick gets half. How many half pizzas do we need then?
5.
5. Yes, thank you. No, I love it, Madison. So that means we're going to eat 5 halves of pizza. What does that mean? Do we need to order more than one whole pizza?
No.
No?
Yeah. Yes.
Let's talk about it.
Oh no.
So Joe's going to get a half. Phil's going to get a half. I'm going to get a half. Rick is going to get a half. Trevor's going to get a half.
Yeah.
So in all, Madison told us we're going to eat 5 halves of a pizza. So the question was, do we need to order more than one whole pizza?
Yeah.
Let's put it in pictures. There's a half. 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 Well, from me, it looks like Joe and Phil, they're going to eat a whole pizza themselves, right?
Yeah.
If we put 2 halves together, that makes a whole. They're going to eat a whole pizza. Rick and I are going to eat a whole pizza, and Trevor's going to eat that last half. So that means, yeah, we're talking about not just one pizza, we're actually talking about,
3
well, 2
and
and a half pizzas. 1, 2 and a half pizzas. So that means what I'm telling you is we can have fractions that represent a value that's greater than 1 whole, like 2 and a half. So, let me explain. By the way, that fraction 5 halves, that is what we call an improper fraction. Good job. Now, let's talk about improper fractions.